Today here on the bench a Kenwood TM-D710 dual bender FM radio, and this FM radio only receives on the left band on this side, but it does not receive here on the right band. So if you like to know what it is all about, follow me along and see if we are able to fix it. Welcome to TRX Bench. Okay, and as always we need to verify if what we know so far is right or not. So therefore let me set both bands here, right and left, to the same frequency. So let's say 430, 100, so that doesn't matter so far. I'm really interested if we have the same receive level or not on both bands, and therefore the easiest way is to put it both on the same frequency. Now the left side is engaged, and of course I can put it here to the right side as well, so both is possible, or the best may be to set it only to one, so that we completely switch one pass off. Then we really can distinguish between these both receiver passes. Okay, so the only thing I have to do, I adjust my signal generator to an S9 level, which is on VHF and UHF -93 dBm. So that is what I've already done, and now I switch on my RF generator, and here we are. So the left side is receiving, and we are having a nice synod level, so which is telling me everything is fine, and we clearly hear our receiver signal. So now let me switch it here to our right receiver, and yeah, let us switch this off, and we can hear barely our signal. So we hear it in the background, and we really have a lot of noise, which is telling me that this right receiver side is not in its best condition. So let's simply compare our figures to see what's really going on. Now, first of all, you can see here what we are feeding in. So that is really -93 dBm, which is representing our S9 level on VHF and UHF, and of course as well on SHF. But anyway, so that is our S9 level, and here we are monitoring our receiver values, and yeah, what you can see here, that our synod is really down to maybe 10 dB or even less, and our THD level is really far beyond what we really want to see at this input level. So that is really bad. And what you can see here on our scope, you see this noisy signal, and it is the same what you can hear. Yeah, I hope you can hear it, that there is really a lot of noise in the background, and that is what you see here as well. So you do not need to hear it, you can simply you do not need to see it, you really can hear it. And now I switch again the receiver back to the left band, and that is what I've done now. And you directly see that we have now a clear sign, and you see that we have here a nice signet level, and of course we have a low distortion level, which is really telling us that this here is a real nice receiving signal. And you see that the difference between our left and right receiver is approximately 30 dB. And remember, our dB figures are a logarithmic figure, so it is not linear, and that means 30 dB is really a huge amount. So there is definitely something wrong. What we need to know now is is it only on the 70 centimeter band, so on 430-100, or do we have the same problem on 2 meter and yeah, mainly on 2 meter. That is very important to know, and it is important to know what gonna happening if we try to transmit, so that all informations we really need to get a clear picture what's going on with this radio. Okay, and I've already dialed in our 2 meter band, and you may already hear that the receive is as well very bad with minus 93 dBm, and yeah, you can hear the background noise. And when I now switch it over, nice and clear, we have a signet of 40 dB, even better than on UHF, and that is, yeah, so the difference now is over 30 dB, so that is really huge. And well, therefore we really know that something is wrong. And here our right band also has a SHF receiver, and yeah, let's check what's going on here. And yeah, I'm feeding in minus 93, and there is nothing, only noise. So if I gonna increase it here a little bit, so let's see. Yeah, with minus 93 there is really nothing, and now you can barely hear a little bit. So this is now 3 dB, and 3 dB is really the lowest level which can be heard, or what we can understand if that would be speech. I mean, it's clear our HF receiver is always a bit weaker than our both VHF and UHF receiver, so that is not the problem. But we see it doesn't matter on which frequencies we are, we have always the right band here, the right side is not able to receive. Now I'm really interested if we are able to transmit. Okay, back to the 2 meter band, and of course we simply want to see what's going on when we transmit. So let's see the figures. Okay, and our upper right display this here will tell us if we have transmit, and the upper left here will tell us if it is the right frequency. So on the radio we have dialed in the 145.290, and let me transmit, and you see 5 watt, so radio is set to low power, which is 5 watt, just fine. And you also see that while I'm talking, we have modulation. So you can see it here at our modulation meter, and of course you see it here on the scope. So that is working, and the frequency is fine as well. So there is a little frequency error, but not too bad. It is very, very close to its 145.290. And by the way, I'm talking, and while I'm talking, this deviation, the frequency is varying a little bit, so that is normal. So here on 2 meter all is fine. Let me simply put it to the 70 centimeter band, and I'm transmitting on 430/100, and you see this is fine as well, so no problem. And yeah, that now is really interesting to know, because we need to understand if the VCO and of course our PLL circuit is working fine. And yeah, both tests which I've done right now has been performed on the right band of our radio. That means, of course, here on this side where we know that we have no receive. But as we are able to transmit on the VHF and UHF band, we know that the PLL is working and the VCO is working. So that is really telling us a lot. And now I wonder where we start our troubleshooting, because yeah, I'm gonna show you in a second the block diagram. So the architecture here in this radio is a little bit different to many other radios. So yeah, let me show you the diagram, then it is much easier to explain. So let's try to explain it here on our block diagram. So you see here our antenna, and we have 2 antenna switches, this switch and the second switch. And very often this antenna switch is switching between the both receivers. Let me call it that way. So that means that this is then maybe the VHF UHF receiver 1, and this is then switching to our second receiver. In this case it is different. So our antenna switches are switching only between, if we go down here, VHF, VHF, and the second one is UHF, UHF. So that means both receiver passes are getting the same input signal, which means that if one VHF band is working and one UHF band is working, it is not something here on our antenna switches or here our filtering. What we have, of course, here we have a high pass filter, and that is indicating only high frequencies can pass through. So that means this is UHF, and this is a low pass filter only. That means that is VHF. Okay, and therefore this both receiver passes are side by side, and if only one band side is working, it is not that something could be wrong here, as we have it very often in other architectures. So thus we need to find something what is only present or not present, which is valid for all conditions. Or let us go a bit more into the schematic, maybe then it is easier to understand. And this here is our complete TX-RX unit, where we have our receiver passes, and you don't see anything? Me too, I don't see anything too. So we have to enlarge it much more, and when we go over to this section, you see that this is a receiver pass, VHF, VHF, UHF, UHF, and this is here our SHF receiver pass, which is only on the right band of our radio. Anyways, what I tried to explain is that if this here is our can we see it here on the right hand side? Let me see. Yeah, maybe we can see it here. So let me enlarge it here a little bit more. So you see here we have our VHF, and you see that the signal, so the VHF signal is really present at both, alright, at both signal passes. Both are VHF receiver signal pass. And when we go down here, we see that this here, both, alright, are UHF signal passes, and so it is really that it cannot be anything in front of this point or this point, and you see really that these both passes are in parallel, if you like, and therefore we need to find something which is which is needed different on the A or the B band. And if we go back to our block diagram, we need to find out what the right band and the left band have in common. So that is now very important. I mean, we have heard that receive is working if the signal level is high enough. So that is telling us that the mixer are working, and that all the local oscillator frequencies must be present. So that is not the point. So maybe it may be that local oscillator output level might be too low, but we have heard that we have receive as long the level is high enough. So that is telling me that it is attenuation, and therefore we need to see what have both passes in common. And well, we see here that we have band pass filters here on each signal pass, and these band pass filters are dynamic band pass filters. So there are capacities, cap diodes, which can adjust the center frequency of our bandpass filter. And if the bandpass filter B driving voltage is not present, then of course our bandpass filters are going to be a kind of attenuator. So we need to check if our bandpass filter voltage is present, and you see that is something what the E band, okay, so that is our A, not E, sorry, our A band, or our left side of the receiver, which is A, okay, for VHF and UHF has in common, so bandpass filter A and bandpass filter A, VHF, UHF. So that means here on the A band our bandpass filter driving voltage must be fine. So a good starting point might be here. Is that good or not? And the second, what we need to check out is if the supply voltage is present for B. Okay, so we definitely have a supply voltage for A, this and that. And what's about our supply voltage for the B band, this and that here? So that is what we need to find out, and I think that is a good starting point, and from there we can then go and find our next steps if with our voltages is all fine. And of course, first we have to crack open our radio so that we get access to our PCB, and that we can start probing here. Okay, and this here is our first look onto the PCB, and what we can see, we have here two PCBs stacked one over the other, and we will take off our speaker here, but there is something I have really directly noticed. So let me see if we can get it into view, and that is really interesting what we can see here. Do you see the same IC? So this here are our little IF filters for A and B band, and what we can see so far, so this is the IF frequency of, let me double check with our circuit diagram. Yeah, and that is what the diagram is telling us as well. So we have for our B band we have 450 kilohertz IF filter here, and we have two of those filters, and 450 is this both here, and then the second is a 455 kilohertz, and that are this both. And these filters here are known for going bad mostly because of humidity, so that is one reason. And the second problem is when these filters are getting DC on its inputs, then they are going bad as well. And as we can see here, corrosion, I really don't know, but you should be able to see it here. So this looks like corrosion, And yeah, therefore I wonder if maybe our filter set here for our B band is completely dead. So that means that we have a high attenuation here on our IF filters. Yeah, and maybe you can see what I mean here on the printout. So we have here for our AB band our 455 kilohertz filters, and we have here our 450 kilohertz filters, and this is of course in the signal path what all our different bands, regardless if VHF, UHF, SHF has in common. So A band, our signal has to pass our 455 kilohertz filter set, and for the B band all signals have to pass our 450 kilohertz signal. Have to pass our 450 kilohertz IF filter set. So therefore that is another portion of our circuit which is definitely suspect so far. Okay, so now I need to yeah, take the speaker off, and yeah, then let's see if we can get here to all the needed test points. Okay, and as we found here our IF filters a little bit corroded, so of course these IF filters are now our first components which are suspect. And well, without any test equipment we can check it out. As I already said, we have two different filters for 455 or 450 kilohertz, and that is due to the fact that we have a narrow band FM and let me call it normal band or wide band FM filter. So that is the reason why we have always two. And to understand it a bit better, let's have a look into our schematic. Yeah, and again our TX and RX unit, and again we have to zoom in. And yeah, let's start here again at the output of our filter, not our filter, our amplifier pass. So what we have seen before, VHF, UHF, and let's simply follow here our pass until we get to our last IF filter set, or our FM decoder or FM IC, whatever we want to call it, and we have it here, and we have it doubled. Let me see. So here is our B band, this here, the right one. This is our B band, and this is our A band. And yeah, our B band is not working, so let's have a look down here and what we can see here. So here we have the first filter for the 4995 megahertz, and this frequency is going here into the mixer of our FM IC, and here we have our local oscillator, which is getting here on pin 1, into the IC, and then you get here somewhere our don't see it, somewhere here's our quadrature pass, and then here we have finally our wideband ceramic filter, and this here is then our narrowband filter. And the easiest way we can check for it is we can switch between these both filters. So now we are on the wideband filter, so you see here the IF, which is going here through our switching diodes, and then we have here our wideband ceramic filter, and this is our narrowband, and we simply switch now between the narrowband and the wideband filter. And if we have then a good receive on narrowband, we are, let me say, 90% sure that it is really only the filter here. And I'm on 2 meter once again, and that is wideband FM, and that is where we have here our bad receive with a signet of 8 dB, maybe 9 sometimes. It's clear, so that is a noisy signal, so that's the reason why it is jumping a bit. And you see the horrible scope picture, so telling us nothing is really good. But let us simply switch to our narrowband filter, and therefore we have to go into our menu. So let me check it here. TX-RX settings, modulation, and we want to change modulation, and we switch now from wideband FM to narrowband. And let me do it this way. So not sure if you can completely hear it. So this is now narrowband and wideband, narrow, wide. So you hear it is much more noisy. So let's go back here to our tester, and so this is wideband. Let me switch now to narrowband, and you see here our figures are dramatically increasing, and you see the scope picture. Maybe it is better if I take away here my lamp a little bit. You see it is much better. I mean, still there is noise, and I mean, I believe that all the filters are not that good anymore, and we have to take into account that they go bad sooner or later. So maybe our A band, which is still working. So this is now a very good proof that it is really our IF filter, our ceramic filters, which are bad here in our radio. Okay, so far we are nearly sure that we have a problem with here our filter, as we have set at our A band our narrow filter into the signal path, and then we saw that the signal synod got much better. So we think that we really have a problem here with a filter. But we wouldn't be at the TRX bench if we would not like to prove that the signal passes we have here, our VHF and UHF signal passes are working just fine for the for the A and for the B band. So that means here at our filter, so that is a crystal filter here in our radio, and one crystal filter is sitting at 4505 megahertz for our A band, and our B band, the crystal is sitting here on 49.95 megahertz, right? And if our complete circuit in front of this crystal filter is just fine, we should really have here at our crystal filter the same signal level on the A and on the B band, right? And therefore we check out our filter level, not our filter level, our signal level here at our crystal filters, and if they are more or less on the same level, we can be sure that we have here a problem with our crystal filter. Sorry, not with the crystal, with the ceramic filter which we have here. Okay, and here on the PCB we have, yeah, we know these are our ceramic filters, and this here are our crystal filters which are sitting on the two different frequencies. And here on the right side, so this is here our A band filter sitting on 4505 megacycles, and we start probing the level right here. Therefore we are using our spectrum analyzer, and the center frequency is now set to 4505 megacycles. So we are now really checking our level at, you know, the crystal filter. Let's see what we can find here. Let me see that I get a good contact here, and here we are. So we are at minus 71 dBm, and that is a very strong signal. It is not modulated, so that is only the carrier what we are testing out here. It's a little bit beneath our frequency, but anyways, we have a strong signal on the A band, and that is clear because we have a good receive on A, but we really want to do exactly the same on B. And of course, therefore, I have here to change my center frequency to, let me double check, I have to set it to 49. Let me see, I have to set it here to 49.95 megahertz, which is dialed in right now. And now I can do the same probing on our B band. So let me see that I get a good contact down here. That is not easy. It's a little bit difficult. I do not really get down here to the test point. So 1 second. Alright, and now we have a good contact here, and you see on 49,950 megahertz we have minus 70 dBm, which is at least 1 dB better than what we had on the A band. So that is now proving that both signals are really on the same level, and that is proving that our circuits in front of our FMIC are just fine, and that is proving that we have faulty ceramic filters. All right. Okay, but how to go ahead? I mean, we know that this here is 450, and it is a CF546 filter. So the one down here, and that is our filter where we have the huge attenuation. So next is to pull it out, and we can check input and or output against the ground, and there should be infinity resistance. If there is continuity to ground, then that is another proof that these filters are broken. So therefore, let me take this filter out. So the CF546 is the wide band filter, and this is a narrow band for the B band. So yeah, first let's take this out. I mean, we can be sure that our local oscillator, which we need to get the frequency down to 450 kilohertz, is working, because we are coming in here, as we have heard it, with 50, what was it? Let me double check. It is 49.95 megacycles. So that is here the frequency passing through our crystal down here, and then of course we need another oscillator, another local oscillator, to mix it up and to bring it down to 450, and that all happens in the FMIC, which is down below. It is not on this side of the PCB. Okay, but we can be nearly sure that everything is fine with the IC and with the local oscillator, as on narrow it was working fine. It was not very good. We had approximately, what was it, 30 dB Senat, which is still a little bit low, but as we said before, all filters here looking not very well, and they all will fail. It is only a question of time. Okay, so anyways, let's take this filter out and let's simply test for continuity. Yeah, we had to loosen all the screws here around the board, and we had to take off here these plugs, and of course here our ribbon cable. And now we still can't really pull it out, as we have here ground connections, and we have still soldered here on our antenna connector. So what we need to do is we have to remove here the solder from these ground points, and we have to disconnect our antenna connector, and then we should be able to lift the board off. Okay, and that is most probably a good job for our desoldering gun. So let's see if it is already working. So yeah, we have here really a lot of ground, and maybe it is really difficult to get it loose here. So a lot of heat is needed, and you already see, that is quite a lot already. And very nice. So it works this way. That is not too bad. But you have recognized how long it took until I was able to get it free. And even now I'm almost not able to really completely heat it here. So that is really funny. It is really a lot of ground what we have to heat up here. And yeah, that is really not easy. That is really not easy. Okay, so we have to do exactly the same, of course, with all this four joints here, and that is not really exciting. So I will do it off camera, and afterwards we have, of course, to clean it, and yeah, then we see how we can lift off the board. Okay, board is out, but a little correction. So you do not need to unsolder this grounds here. So you simply need to take the screws out, and we have underneath our power amplifiers. You can see both here. All right, and yeah, one is for VHF, one for UHF, and yeah, so they are screwed here to the chassis, and chassis is of course the heatsink. So you simply need to undo the screws, and that's it. Alright, so now I have here access to our filter. And let me simply take out here our first filter that I can check it. Okay. Okay, so here is our filter, and as I said, we should not have any continuity or even a resistor between input and ground, or output and ground. So we have here three ground leads, and well, normally we really should have infinity resistance between any of our input or output pin. To ground there should be infinity resistance, and if there is any testable resistance, then this is a clear sign that something is wrong. So yeah, let me simply here connect, I do not know, is it input or output, so it really doesn't matter. Let me simply connect it here, and let me see if we can get both somehow here into our picture. And let me connect one pin, and yeah, so that is a clear indication. So we have 300 ohm to ground, which is definitely wrong. So this filter is definitely toasted, and that is the reason why we have this high attenuation. So here it is 72 mega ohm fine, and it's not fine, as it should look like this here, overload. That means infinity resistance, and here from the other side, input or output, that doesn't care. So we have here 14 mega, which is not infinity. I mean, it is quite high, but it is not as it should. Well, a lot of passes don't look that bad, but here, this here is definitely the reason why we have this high attenuation, because the signal is simply connected to ground over this resistor, and yeah, that is the reason why there is no receive. Okay, there is nothing else how we could prove it more. So let's see that I can get this filter. And I mean, once again, if we, let me see how good we are able to bring it into, I think you really can see it here, and we really have a lot of corrosion down here. You simply can see it. And these filters here are the good ones. I mean, no problem on the A band, but how long will it take until these filters are also shorted to ground? So therefore we will swap out all four, and then we should have this problem under control. Alright, and the new filters are arrived. So we have here our 4 new filters, and I made here a little diagram to exactly know where the new filters have to go. So here on the right hand side we have our A band, and the left hand side is our B band, and the upper filters are the narrowband filters, and the lower are the wideband filters. So that is what we have to do. So we pull out here the old filters, and then we put in our new filters. Okay, so let's go ahead. Okay, and we have here through contacts on the PCB, and we have really a huge ground plane. So we really need to heat this solder points up, and yeah, so that might take a while. I take here my desoldering gun for this job, of course, and yeah, we really need to be careful to really heat up the whole ground plane, so that take a while. So therefore I heat it a few seconds, and then I try to suck it, and yeah, so that seems to be loose. So that is definitely a problem. So sometimes it is really not easy to get it really hot enough to be able to suck all the solder out of our through hole connection. So now here we have already this problem. Even I really heated it up, so that is definitely something we need to be very careful with. Now it is loose, and so we really have to go around and to get here our old filters out of the PCB. But as you see, it is a kind of boring, so we do not need it all on camera. Let me simply take the filters out, and then we populate it with the new filters, and let's see if we have then our performance back here as we want to see it. Yeah, now we can take our filters out like so, and yeah, we can definitely replace our new filters into it. Okay, so and now let us verify what we have heard about the resistor between input, output and ground. So let me take here our CF546, which is B band and white, which was our band where we had no reception. And so let me simply take this here, and let us check what the resistance is between our pins. So now I have double checked it. So this is here input, this is output, and these 3 pins down here are ground. And as we heard, we should have infinity ohm, and yeah, let's see if that is true. Okay, and let's try if it works this way. So I have connected here our filter, our new filter, and you see input to first ground infinity, second infinity, third infinity. Okay, let's change to the output, and let's simply do the same, and you see still infinity, and second one infinity, and third one infinity. And that is exactly what we want to see. So this filter, the new one of course, is just fine. So let me drop it, and that you see it was no fake. Here our meter is working just fine, as you can see. Let's put our new filter by side, and I have here our 3 filters which we take off. And yeah, simply let's do the same test. And remember, the 3 filter we have taken off today were not completely fine, but we have seen that it was still working. So let's see what we have, and you immediately see that it is not infinity any longer. So it is still, of course, in the mega ohm area, but not here. So here's the filter which is on 300 ohm, and it may be that it is now induced a little bit by the heat, that it is now exactly that bad than the filter we have taken out first on our B band, where we have seen our fault. But anyways, so you see this filter is bad as well, and that was the indication. So the corrosion or the little dots, whatever. So let's take a second one, which we have seen on the outside of the filter, and this filter here as well. So it is definitely not infinity, right? And 122 ohm. So you really see all these filters are definitely bad. Now the third filter, what we have left so far. So let me connect it, and let's see. Yeah, 30 mega ohm, which is not good. Second ground, 20 mega ohm. Third ground, 9 mega ohm. Let's go to the input pin here, and 5 mega ohm, and 22 and 23. So which is not good. And yeah, so that is what I wanted to show you. Even if it was not directly obvious when we connected the radio to our communication tester, it is really only a question of time when this, or until this filters will fail completely, as we have seen it with our first filter which we have taken out. So therefore it is really a good idea to swap out all four, because yeah, how long does it take until this will go finally faulty? I don't know, but it doesn't make sense to leave them in. And of course, before we gonna populate it new, we clean here our PCB with FluxX, which is a very good flux remover. So that is what we are gonna do first, and then we put our new filters in. And interesting enough, the new filters are not Toco any longer, so whatever that means. So this is an original Kenwood part. It is not from the free market, so it is directly from Kenwood, and the replacement is not Toco any longer. So what does it mean? I have no clue, but maybe that the production quality of Toco is maybe not that good, so that they have changed here their manufacturer. Okay, so what we have to do right now? So we have, of course, to populate the new filter into its place, and you really need to carefully look where you put the different filters, because just to remember it, we have 450 kilohertz filters, midden frequency or center frequency, and we have 455 kilohertz filters, so left 450, right 455, and we have wideband and narrowband filters. So you really need to be careful when you start populating your new filters, that you do not mix them up, because otherwise it will not work. So that is really important to consider. And then after that, first filter is in, and what I do always, I do not really solder all the solder points, so I always only solder one. And let me do it. Can you see it here a little bit? Maybe. So I only do one solder point first, like so, and then when you have done that, so it is tucked a little bit, and then you put a little force here from the top side to the filter, that you really get it in place, so that it is not wrong in here inside your PCB. So you put a little force, let me see that you can see it, you put a little force onto your filter, and then you put your solder iron once again to the solder point, and now you can be sure that it is fitting here into the PCB just fine. And when you have done this, you can go and really solder all your needed contacts to the PCB, and everything is fine. our new filters are in, and the only thing left is to clean once again here our solder points. But we don't need now this strong flux remover, so we simply clean it with alcohol, and then it will be just fine. And of course we remove here our grease, our heat component, and we do some new grease onto it, and of course we do the same here on the chassis. So we take off all the old and put on new, then all is just fine, and I can then put back our PCB into the chassis. Okay, so all is back in place, so the only thing we have to do is to put back here our speaker chassis into its place, and yeah, then we are ready for testing. Okay, so let's test now our set. Switch on, and yeah, the radio communication test is already connected. So you see on band A, right, so we have here a full indication with minus 93 dBm, so that is just fine. And now our B band was our problem band, so let's switch over with the same frequency to the B band, and let's see what we have there. And here we are. So B band with full indication, and with a great synod figure on the tester. So let me swap over. Yeah, and have a look. So that is really great. So you see now we have a synod of 45 dB, and remember, on A band I do not remember completely, but when we go back to the first test when the radio came in, we saw that even on the A band, which was our working band, we had a synod of about 38, so we need to rewind back to where we have tested it. But in any case, we have a real improvement here. So now A and B band is working just fine. So we have approximately an improvement even on the working band, so on the A band of about 6, 7, 8 dB, which is really awesome. And the same and this is of course now our B band, and that means we have really good performance here now. Everything is working just fine. Okay, but let's test here our 70 centimeter as well. So of course it is not dialed in, so 430 100 megahertz, and let me put it here, and you already see. So it is receiving like new, so a very good synod, and everything is just fine. And let's go and check as well here our 1297. And now I have a little problem. I have to change my generator, as my trusty Rohde and Schwarz only goes up to 1 gigahertz, and now let me put it here all on my trusty HP to test also our SHF frequency. Let me connect it over to the HP. And here we are. Even our SHF is working just fine on the B band without any problems. So finally we really can be satisfied. Everything is working just fine and as it should. So we can put it all together, and we simply can give it back to the owner. And at the end of this video, one additional information. So yes, this fault is known with this Kenwood series. So it is known that our IF filters, our 450, 455 IF filters, are a problem with this radio. But you know, if I would have gone directly to the filters and okay, we need to swap out the filters and everything is fine, then you wouldn't get the entirely view. And I just wanted to show you the right approach. First of all, when you start a repair, you always should have a view into the schematic and just make yourself a plan how to approach. And then when you go and open up the radio, never forget your best testing gear, which is your eyes and of course your nose, right? And that is what we have done. So we have figured out a first approach, and we thought, okay, let's check this and that, and then we opened the radio, and you always need to look over the board if you see something what is not as it should. So you really should take the smell. Is there something burnt or so? So that is the approach you always should go. And yes, of course, we directly could have gone to the filters and swap it out, but yeah, you should decide for yourself what was a better way, just to show you how you can manage faults like this, or directly go to swapping out these filters. Okay, so that's it for the day. Radio is ready to go back to its owner, and I hope it was a little bit enjoyable for you. And if you like it, please give me a big thumb up for this video, because a thumb up really helps. And yeah, see you next time, and bye.